Now we have the basics for bases under our belt, we want to talk about coordinate systems. So when working in Rm, we normally express a point as an ordered M tuple. Let's say P, which is equal to x1, x2, down to xm. So we call these the standard coordinates for Rm, since we can identify P with the vector v equals x1 e1 plus x2 e2 plus etc. plus xm em, using the standard basis, which we'll denote by the script e, whose elements are e1, e2, down to em. So as a quick example, let's think about R3. We usually, by convention, use the coordinates x, y, and z. So for example, we can specify a point using three equations. We can set the x-coordinate equal to a number, let's say 1. We can set the y-coordinate equal to a number, let's say 2. And we can set the z-coordinate equal to a number, let's say 3. We identify the point 1, 2, 3 with the vector v, which can be written as e1 plus 2e2 plus 3e3. We're able to do this because the set of vectors script e equals e1, e2, e3 is in fact a basis. Now, we know from our previous videos that there are other bases other than the standard basis. So if script b is a set consisting of vectors v1, v2 through vm, forms a basis for Rm, then we have a different coordinate system, say y1, y2 through ym, corresponding to each of the vectors in our basis, so that we can write a point in Rm as the ordered M tuple y1, y2, dot, 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 then to ym, which we subscript with a b to indicate that this is the representation in terms of our basis with elements v1, v2 through vm. And this notation corresponds to the linear combination y1, v1 plus y2, v2 plus dot, dot, dot plus ym, vm.